Alright guys, so topic 14 is going to be all about infectious diseases, something that you guys must be very well aware of now that we're in 2020 or 2021 whenever you watch this video. Starting off, Louis Pasteur and Robert Nook basically established an actual set of rules that help explain how infectious diseases happen. Infectious diseases are usually caused by microorganisms, and eventually these microorganisms ended up becoming germs due to the fact that they became part of the germ theory. So agents of diseases. Agents of diseases are just anything that's infectious and is caused by a pathogen, such as viruses, bacteria, fungi, parasites, any of those. Once they enter your body, they kind of just make a whole mess, and then that will trigger into some kind of disease. Viruses are non-living particles. They basically inject themselves into your cells, spread their genetic material, and end up giving you some kind of disease, such as the virus, the flu, COVID, warts, chickenpox. Bacteria are going to be a little different. They're actually just going to break down in the tissues. They can be traveling through food, and they will cause things like anthrax or streptococcus infections. You also have funguses that can attack you, usually around the skin, mouth, throat, fingernails, and toenails, and that's how you get athlete's feet. Now, Koch's postulates basically is like a checklist on what makes a microorganism that is specific to diseases. The first one being that it must be found in a sick organism, but cannot be found in a healthy one. The second one is basically that if I took a sample from you and isolated it, it should be pure. Now, if I took that and introduced it to another host, they should end up with the same type of disease that you first had. Once the second host has it, I can take a sample from them, and that's where number 4 comes in. It should be identical to the sample that you would take from the first host. There are some exceptions to these rules, but these are the basic guidelines on emerging diseases. Now, how does disease spread? You guys should be very well aware, since we're all in high alert in how to spread diseases. You know, usually it can happen through physical contact, coughing, sneezing, any type of bodily fluid exchanges. It can happen through contaminated water. It can happen through any form of contamination. So in pathogens, the major symptoms are usually diseases such as sneezing, coughing, diarrhea. You also have the host can start acting a certain way. Now, when we talked about previously natural selection, we talked about how you favor someone who basically tries to survive as long as they can in order to generate. Infectious diseases such as viruses are not exempt from that rule. So now if the host dies and the virus doesn't spread, the virus just dies. So it's more favorable if the virus or bacteria actually manage to reproduce in order to quote-unquote win at biology. Now this usually happens by infecting the nose, throat, and respiratory tract in order for you to spread the virus or disease or bacteria by sneezing, coughing, touching things, any kinds of droplets that you have, which is why specifically for COVID, masks and social distancing is such a major thing. Those droplets can be inhaled by anyone else, and it's going to allow an easy spread from host to host. Yeah, alright. So we talked about how the spread of bodily fluids. That also does include sexually transmitted, which can include viruses or diseases such as herpes, gonorrhea, syphilis, and chlamydia. You guys would have done, if it was any normal year, a sort of lab where you all get a cup. One of those cups is infected with NaOH, it's just a base. You would have to exchange drops with different members of your class. Once you're all done, you guys get quote-unquote tested, which means I would have put an indicator into your cups, and if you're infected, it turns pink. Now, the main thing is for you guys to see that if I were to give one of you guys the quote-unquote disease, that person will then interact with like 10 other people, and those people will interact with 10 other people, and eventually the majority of the class would have been infected. There is contamination in food and water. There was a case early on where a lot of people were getting, I want to say, cholera, and a scientist looked into that and basically just turned off the tap. Basically, that one pump where people were getting their water and they started getting cholera from and spreading it was just infected water. Contaminated food and water is one of the major issues when it comes to spreading diseases. It's easier to spread because you all could share water, you all could share food. Zoonosis. So zoonosis is basically just when we're transmitting a disease from an animal to a human. That includes SARS, Lyme, Ebola, and the bird flu. Um, Moving on from that, just basically know that that's when you get a disease that's transmitted from an animal into a human. Now, your body has a set of defenses. You have both non-specific and specific defenses. Non-specific are your basic general things. So when you guys get something in your eyes just start to tear up. That is a defense. It's basically trying to excrete whatever was in your eye. You have your skin that forms an extra layer so that it's harder for bacteria or any kind of infectious agent to get into your skin. You have mucus, also inflammatory responses, and interferons, which we'll talk about later, also fevers. Now, why is it called non-specific defenses? It's because it's not targeting one specific quote-unquote person. It's just it's a blanket immunity. The fever will increase your temperature in order to kill whatever is inside. Your inflammatory responses will basically just be there in order to get white blood cells into that area. Your tears are just trying to get whatever it is out. It's not looking for a specific infection. And your skin is just a protective layer for basically anything you come in contact with. We kind of already talked about that. Your second line of defense, it gets a little more specific. Now, it does include inflammatory responses and actions of interferons and fevers. That's one to get inside. So your skin and tears and mucus and everything are to prevent things from coming inside. Once it's inside, you have things like the inflammatory responses. Like I said, the infected area basically becomes red, puffy, and painful. If you've ever gotten a cut, you'll see that it kind of gets hot. That's because a lot of blood is rushing to the area. It's all because it releases histamines in order to get more blood flow in that area. That's what causes the whole heat and inflammation. Once that's done, it'll release white blood cells into the infected area. The white blood cells will basically go through phagocytosis, which basically just means that they will eat the intruders in that area. Now the interferons, they basically are just there in order to kind of create a stop button for viral growth. We told you at the beginning, a virus basically gets around by making copies of its genetic material. The interferon is there to make sure that that stops. And again, fevers basically increase your blood pressure in order to either slow down or just completely stop and kill any kind of pathogens. Now, if you're in your house, you know who lives with you. If a random person walked into your house, you automatically know that they don't belong there. They're not part of your unit. They're outsiders. And that is exactly what your body does. Your body identifies self and non-self. It will recognize cells. Now, there are exceptions to this. Sometimes you will get an autoimmune disorder in which your body has an issue telling itself apart from others. But for the most part, a working immune system will recognize itself and be able to treat its normal proteins and everything as self. Once a foreign non-self comes in, you go through an automatic immune response. Now, there's different ways you can do it. So antigens, first of all, are foreign substances that can start the whole triggering of the immune response. Again, they can be things like bacteria, parasites, and viruses. The way that the immune system responds to the antigen depends on what kind of immune response it needs in order to get rid of it. Sometimes it will create these things called antibodies. So antibodies, what they basically do is they will attach to the antigen. They're usually in this Y shape. It's kind of like a flare. And if you didn't recognize that someone was in your house that you didn't know, it's like your house just randomly putting a spotlight on that person. Like, hey, this is not self. You also have lymphocytes. So when we're looking at lymphocytes, you have two types. You have B lymphocytes and T lymphocytes. Both of them basically are produced in the bone marrow. The B cells will continue to grow to maturity in the red bone marrow. The T lymphocytes will actually mature in the thymus? Yes, thymus, which is just an endocrine gland. Their specific roles we'll get into in a second. We already did that. Alright, so the immune system actions. You have humoral immunity and you have cell-mediated immunity. So humoral immunity basically is where the B cell plays a major role. it's going to attach a antibody to it, and then the B cells will kind of go into that area. Your main thing here for humoral immunity is that you have antigens. Now, cell-mediated immunity, same, it will identify self and non-self, but it is more based with its own cells than anything. So if a cell becomes infected, this is where your cell-mediated immunity comes into play. Sometimes your cell, like right now you're sitting down, you can be quote-unquote going through and creating cancer cells, but your body will quickly fix that. The only problem where you actually have developed the cancer is when the cells start to divide out of control and it actually becomes a problem. But for the most part, your body keeps itself in check. If something is wrong with the cell-mediated immunity will come and get rid of any issues. Again, we went over humoral. You have the Y-shaped antibody that will attach itself to the antigen so that they can come in and grab them. So you have plasma cells and memory cells. Once you have the antigen binded to the antibodies, the B cells will grow and divide rapidly. Through that division, you will have plasma cells and memory cells. Plasma cells basically will release antibodies that will kind of mark the cell for destruction, and the cell will go through apoptosis, which basically means it's just going to bomb itself. It's going to explode from the inside out. But you're still going to be left with the memory cells. Now, the memory cells is if I had taken a picture of someone in my house that wasn't cell so that I can remember how to react to that person. And that is what your body is doing. It's keeping a record of every foreigner that came into its quote-unquote home. We went through that. So your cell-mediated immunity, it's a little different. It has more to do with macrophages. The macrophages are just these fat, giant cells that will come around and swallow the antigen. Once it swallows the antigen, it will kind of release this kind of like signal in the surface to let your T cells, which are cytotoxic cells, know that something is wrong with that cell. Once it starts the division of cell, So the T cells, the helper T cells, will slowly divide. Once they get the flag signal, you will get the cytotoxic T cells, which will basically help set that cell up for apoptosis. The cell will then explode. Again, it will make a memory T cell in order to remember what to do when it gets to it. The cytotoxic T cells, I'm going to show you guys an amoeba sister video later on that will basically summarize it, but basically just know that it's basically a quote-unquote hunter that will get rid of any infected cell. Through that, autoimmune disorders. Alright, so it talks through here, it talks a little bit here about organ transplants. Now remember, I told you guys that the body identifies self and non-self. Now that is a problem, because if you're getting a heart transplant, your body can recognize that heart or the new heart as self or non-self. Should it recognize a non-self, immediately your body will go through an autoimmune issue where it will try to basically tear apart that tissue, which is one of the main reasons where you have a rejection of an organ. So if it doesn't line up properly, your body will basically infect that new tissue and you're going to end up needing another transplant. They usually have medication in order to help lower your immune system to get your body to accept that as part of you, but it's a major issue when it comes to organ transplants. Alright, so acquired immunity versus active versus passive immunity. We're going to go through acquired right now because it's a major thing that we are facing currently. So active immunity means that you yourself have earned that immunity. You have had the disease, you have fought that disease, you have won. Now passive immunity is different. If I gave you a vaccine, you yourself never experienced it, but you do have the antibodies prepared in case you do meet that thing. So that is a form of passive immunity. Now there's also the fact that for the first 3 months, if you're breastfeeding a child, the child will get mom's immunity, and that is passive immunity. The baby has not earned that immunity, it is borrowing it. Now let's go back to acquired immunity. The reason I skipped it is because there's a little bit more to say specifically with what we're going through right now. So acquired immunity, basically you can simulate the immune responses with the antigens. Your body will end up getting those memory cells and your body will have a quicker response to it should you ever see that pathogen again. Now the way that we ended up with things like vaccines, there was this guy, he's kind of a jerk. He saw that while a lot of people were getting pox, the milkmaids didn't. they had previously gotten cowpox. That means that the cowpox and the smallpox were kind of similar. He basically saw that because they were already exposed to it, they were sort of immune to it. So his immediate thought was, you know what would help this? If I grabbed a young boy and just kept pinching him with the virus to see what would happen. I mean, nothing happened to the young boy, but it's not very ethical the way he went about creating the first vaccine. So he is quoted for the whole smallpox infection, finding a new form of vaccine, which came from the actual cowpox, by creating a mild form of the virus that he injected into a small boy. The small boy basically began to create those antigens, those antibodies, so he couldn't get smallpox. The main reason this is important is because right now we're going to face something similar. Not that no one's been poking some random kid with cowpox, but we are experiencing a new form of vaccine. So there's a lot of uncertainty with that you guys may feel, but for the most part, it goes through a bunch of checks to make sure that there's no issue for the host. So vaccination comes from the word cow, vaca, cow, vaccination, because the original vaccine came from cowpox. Vaccination is a form of getting you guys that immunity without you actually having to experience the full onset of that disease. There is actually no scientific proof that it creates things like autism. It is just a way for your body to get that introduction to some sort of pathogens. Now, the way that we're going through health to, let me backtrack a second. So a lot of the stuff that we go through are just basic public health measures to help prevent diseases. And that means things like regulating food and water supplies, promoting vaccines, and kind of limiting the amount of infections. That's why right now, currently, we're going through the whole social distancing thing where we don't want more than 10 people at one place. Everyone should be at least 6 feet apart if they can be, with masks at all times. Some maybe face shields, kind of isolate in order to get a hold of the virus. It's the same thing. They're all kind of public health check marks that we're putting in place to decrease the amount of exposure to any kind of antigens. You do have antibiotics that are there. They kill bacteria, and some antiviral medicine will slow down viral activity. However, if you have a virus, an antibiotic will not help you, because an antibiotic is designed specifically for a bacteria. That is an issue that we actually have. I'm going to go off book for a second. I think it talks about it like right after. A lot of doctors, when you come to them with a cold, now cold again could be viral. If they are not sure, just to get you out of the office, sometimes they will give you an antibiotic. Now that's great, you will feel good. The problem is, some of you will have like 10 pills and you'll take 5, realize you feel better, and you'll stop taking the antibiotics. So now what you've created inside of your body is a virus or bacteria that is no longer affected by that particular antibiotic, because you have shown it a sample but you did not kill it. So now it's going to grow, and basically you're going to become quote-unquote immune to that antibiotic, and that's what's causing a major issue, because some of us are becoming immune to antibiotics because we're taking large amounts that we do not need. And if we are taking it, we're not taking the full set. You guys should be taking, if you have 10 pills, 10 pills. If you have 5 pills, 5 pills. Just because you feel better does not mean that the bacteria or virus is dead. We also have a bunch of infectious diseases. You guys know this. You guys are living in 2020 or 2021 or wherever you're watching this. But you're living in a post-COVID world. One of the major things that we are doing in order to prevent these major diseases from coming back is promoting vaccinations of small children. There is such thing as herd immunity. That being said, if a child gets a disease, it can mutate in the child, and then they will infect you with a new strand of something you're not immune to. So we have, in the past couple of years, been seeing the you know what? I'm going to use the word anyway. The respawning of previously thought long gone diseases. Why? Because they're mutating inside children who are not vaccinated. And then they are spreading it to the public who may or may not be vaccinated. The only reason you should not be vaccinated is if you have an immunocompromised situation where you just can't handle that vaccine. We went over the antibiotics. Yeah, new and re-emerging diseases, just like I said, a lot of things that we thought were long gone are slowly making their way back. Changing interactions with animals. Remember, some pathogens can hop from animals to humans. The main issue is that we are basically clearing area of environments. The animals then will have to relocate, usually in a way that will change the interaction between humans and animals, that will allow direct contact, which causes us to allow the hopping of pathogens from one organism to another. You'll also have the exotic animal trade. If you guys didn't watch Tiger King, maybe watch it, but basically that's what you saw. You saw that there's a reintroduction of organisms that we don't naturally meet up with, and that's allowing opportunities for infections